The Austrian engineer walked into the Führer's chambers on a cold March morning in 1942. His blueprints tucked under one arm. Ferdinand Porsche carried with him something he was certain would change everything on the battlefield. The papers he unfolded showed sketches of a machine that promised absolute dominance, a 100-ton tank that would obliterate every vehicle the Allies could field. Yet 2 years would pass before his vision took form, and when it finally did, reality had a cruel way of disappointing ambition. The finished tank weighed 188 tons and moved at barely 13 kilometers per hour, slower than a man jogging through morning mist. While Porsche's craftsmen labored meticulously over their creation in German workshops, filling the air with the deafening percussion of rivet guns, something entirely different was happening across Europe. At Tankergrad in the Soviet Union, factory workers were pulling completed T-34 tanks from production lines at a staggering pace, 1,300 tanks every month. The rhythm of Soviet manufacturing followed no aesthetic philosophy. Speed mattered more than perfection. Rough welds and loose tolerances were not flaws, but features that allowed ordinary workers to assemble machines quickly enough to replace those destroyed on the battlefield. Across the Atlantic, American factories hummed with their own industrial symphony. In Detroit, workers who had assembled automobiles just months earlier were now using those same mass production techniques to build Sherman tanks with relentless efficiency. These weren't masterpieces, they were tools cranked out with standardized parts and assembly line logic, each one costing $58,000 and reaching the battlefield in 6 months. German leadership looked at these numbers and drew the wrong conclusion. If Soviet tanks at 45 tons were devastating their lighter machines, surely something weighing 188 tons would dominate the field. The fatal misunderstanding had begun years earlier, on June 22, 1941. That morning marked the start of Operation Barbarossa, and it shattered everything German tank crews believed about armored combat. Panzer III commanders, who had grown accustomed to punching through Polish and French vehicles, found themselves facing something terrifyingly different. The T-34s' sloped armor deflected their 37mm rounds as though they were pebbles. Meanwhile, the Soviet 76mm gun turned their carefully engineered machines into flaming coffins at distances the Germans thought safe. Field reports poured into Berlin with a message that grew more chilling with each transmission. German armor was obsolete. Engineers studying captured T-34 blueprints realized the Soviets had achieved something remarkable through apparent crudeness. The tank weighed 45 tons, yet moved faster across broken terrain than anything in the German arsenal. Its sloped armor wasn't just efficient, it was revolutionary. The wide tracks distributed weight so effectively that the T-34 traversed swamps where German tanks sank until their turrets disappeared beneath mud and water. Most troubling of all, Russian workers built these tanks quickly because they didn't demand perfection. The German response seemed inevitable. If heavier Soviet machines were outperforming lighter German tanks, the solution was to build something bigger, thicker, and more powerful. The Tiger Y emerged in 1942, 57 tons of armored fury, mounting the legendary 88mm gun that anti-aircraft crews had proven could penetrate anything. Tiger crews achieved stunning kill ratios against Soviet forces, with ace commanders destroying entire tank companies in single engagements. But Porsche envisioned something far more ambitious. The portly Austrian, whose engineering brilliance had created the Volkswagen Beetle and revolutionized transmission systems in the 1920s, saw the Tiger as merely a stepping stone. In his Stuttgart workshop, he sketched plans for a machine so revolutionary it would render every Allied tank obsolete. His concept called for a 100-ton colossus protected by armor so thick that no existing weapon could penetrate it. The tank would mount a naval-derived 128mm gun capable of destroying targets at ranges where enemy weapons couldn't reach back. Porsche's signature innovation was an electric transmission system. Diesel engines would generate electricity that powered electric motors driving each track. This arrangement, he argued, would provide reliability while eliminating the mechanical complexity of traditional gearboxes. More importantly, it would allow the massive tank to pivot on its own axis, bringing its main gun to bear with unprecedented precision. When Porsche presented these preliminary designs to Hitler on that March morning in 1942, the response exceeded even the engineers' optimistic expectations. Hitler, who had witnessed firsthand the carnage of trenches in World War I, grasped immediately the psychological power of what Porsche offered. Here was engineering supremacy made physical, a technological marvel that would prove German ingenuity to the world. The project, initially called VK100-1 and later renamed Maus, consumed Porsche's organization with unrelenting intensity. At Stuttgart, teams of Germany's finest engineers confronted unprecedented challenges. The tank's weight climbed steadily as armor thickened and the gun mount strengthened to handle the massive 128mm weapon. Each solution created new problems, demanding additional weight and complexity. The electric transmission system, Porsche's pride, required an entirely new approach to tank design. Unlike conventional tanks where the engine connected directly to the gearbox, the Maus needed separate diesel generators to power electric motors distributed throughout the hull. The entire central hull had to be devoted to power generation and distribution. This created a nightmarish arrangement where the driver sat isolated in the front while the five-man turret crew operated in complete separation. Communication between compartments became nearly impossible over the roar of diesel engines and the whine of electric motors. By October 1942, the project had ballooned beyond recognition. The tank now weighed 150 tons, and Porsche's engineers were wrestling with fundamental physics. The meter-wide tracks were sinking into soft ground under the immense weight. Every bridge on the European continent had load limits the Maus exceeded dramatically. River crossings would require specially designed snorkeling equipment, allowing the tank to drive across riverbeds while submerged to 8 meters deep. Yet Hitler remained utterly captivated by Porsche's vision. On May 14, 1943, presented with a wooden mock-up at his headquarters, the Führer immediately ordered 150 units for immediate production. It would be exactly that, a giant, he declared, overruling officers who questioned the tank's tactical utility. The project officially became known as the Maus, Hitler's ironic name for the behemoth that now weighed 188 tons. While Porsche's teams wrestled with engineering impossibilities, Allied production reached devastating efficiency. At Detroit's Chrysler Arsenal, former automobile workers applied mass production techniques to tanks with relentless precision. The River Rouge plant, which had produced Model T automobiles, now manufactured M4 Shermans using the same standardized processes Henry Ford had pioneered decades earlier. In the Soviet Union, Tankergrad was producing 1,300 T-34s every month, their crews learning to operate machines during the short drive from factory floor to combat. Soviet engineers had simplified their design for rapid production, eliminating unnecessary complexity in favor of speed and reliability. The arithmetic was becoming impossible to ignore. In 1943, German industry produced 11,000 tanks of all types combined. American factories alone manufactured 29,197 that same year. The Maus wasn't competing against individual enemy tanks. It was racing against an industrial tsunami threatening to drown German forces in sheer overwhelming quantity. The first prototype, designated V1, rolled out of Alket's Berlin facility on December 23, 1943, looking more like a concrete bunker placed on tracks than a mobile weapon. Without its turret, the hull alone weighed 133 tons, equivalent to 5 Sherman tanks combined. The Daimler-Benz engine, a modified 40-5-liter aircraft power plant producing 1,080 horsepower, struggled to push the massive hull beyond 13 kilometers per hour on level concrete. Porsche's engineers had promised 20 kilometers per hour, but reality was proving far more stubborn than their calculations. Chief engineer Karl Hacker watched the first test runs with mounting unease. The electric transmission system that had seemed so elegant on paper revealed catastrophic flaws under actual operation. The diesel engines ran constantly at high RPM to generate electricity, consuming fuel at alarming rates that made operational deployment impossible. The tank burned through 400 liters of diesel every 100 kilometers, 8 times the consumption of a Sherman covering the same distance. At that rate, the Maus would drain Germany's already stretched fuel reserves faster than U-boats could replace them. Engineering problems cascaded through every system. The meter-wide tracks supposedly distributed the mouse's weight effectively, but mathematical calculations hadn't accounted for dynamic loading during acceleration and turns. When the massive tank attempted even gentle maneuvers, the tracks dug deep furrows into earth that should have supported the distributed weight. Test runs at Kummersdorf scarred the proving ground with trenches requiring engineering equipment to repair. Bridge crossings became exercises in structural engineering rather than tactical movement. The Maus exceeded the load capacity of every bridge in Germany, including massive concrete spans built during the Autobahn construction program. Porsche's solution was typically ingenious and completely impractical. The tank would cross rivers by driving along the bottom while completely submerged. A complex snorkeling system provided air for the crew and engines, while waterproof seals protected the electrical systems. The theory was sound, but execution required the Maus to operate in pairs. One tank submerged and crawling across the riverbed, while its partner remained on shore, providing electrical power through an umbilical cable. The first attempted river crossing at a Spree tributary near Berlin demonstrated the nightmarish reality of Porsche's underwater solution. The lead tank descended the bank and disappeared beneath 8 meters of murky water, the snorkel tube marking its location. Inside the submerged hull, the 6-man crew endured claustrophobic conditions as water pressure stressed every seal and gasket. The crossing took 47 minutes for a river that a Sherman could ford in 3 minutes using conventional methods. Worse, the tank emerged coated in river-bottom sediment that clogged cooling vents and fouled electrical connections, requiring hours of maintenance to restore any capability for operation. Meanwhile, at the Škoda works in Pilsen, Czech workers were manufacturing the Maus's 128mm L-55 gun under the watchful eyes of German supervisors. The weapon was a marvel of ballistic engineering, capable of penetrating any Allied armor at ranges exceeding 3,000 meters. Test firings against captured Sherman hulls demonstrated devastating effectiveness. The massive projectiles tore through enemy armor and demolished entire tank sections with devastating force. Yet each 128mm shell weighed a hefty 28 kilograms and stood nearly a meter tall. This meant the Maus could carry only 61 rounds of main gun ammunition. Compare that to a Sherman tank, which carried 71 rounds for its 75mm gun. Each of those rounds weighed just 6.3 kilograms and demanded far less storage room. This ammunition shortage revealed the Maus's deepest weakness. To fit those enormous shells, Porsche's design team had to sacrifice space that other tanks reserved for crew comfort, spare parts, and additional systems. The loader, wrestling with 28-kilogram projectiles in a confined turret space, would be utterly spent after firing a dozen rounds. Combat effectiveness collapsed rapidly as the crew exhausted themselves handling ammunition twice as heavy as anything the Allies carried. Porsche himself became increasingly obsessed with solving each technical problem. He'd drag engineers from their beds at midnight to address even minor mechanical issues. His Stuttgart workshop transformed into a crucible of perfectionist engineering, with teams grinding through 18-hour shifts, refining electric motor controllers and diesel generator assemblies. But each fix brought new complications, demanding more weight and greater complexity. The Maus had ballooned to 188 tons, and Porsche's engineers kept adding systems. Improved ventilation here, redundant electrical circuits there, enhanced armor plating for vulnerable spots. The comparison with Allied manufacturing was becoming impossible to ignore. Detroit's Willow Run facility applied assembly line techniques to B-24 bomber production, completing one aircraft every 63 minutes using standardized parts and streamlined procedures. Sherman production at Lima Locomotive Works followed similar principles. Modular designs, interchangeable components, manufacturing optimized for speed rather than chasing perfection. Each Sherman demanded roughly 75,000 man-hours from raw steel to battlefield readiness. The Maus prototypes were consuming over 2 million man-hours each, not counting the specialized tooling and testing equipment for their unique systems. Soviet tank production had embraced even more radical simplification. At Factory 183 in Nizhny Tagil, T-34 assembly lines eliminated anything non-essential to maximize output. Interior surfaces remained unpainted. Electrical systems used only the minimum wiring necessary. Armor plates were welded for function, not appearance. Soviet workers, many of them women and teenagers replacing men sent to frontline positions, could assemble a complete T-34 in roughly 42,000 man-hours. The tanks lacked German refinement, but they were dependable, fixable in the field, and available in staggering numbers. The Mause's electric transmission system, Porsche's signature innovation, proved particularly troublesome under real operating conditions. The electric motors generated tremendous heat that overwhelmed cooling systems, causing repeated shutdowns during extended tests. The complicated electrical controls demanded constant tweaking by technicians who understood each prototype's quirks. There were no spare parts from other sources. Field repair procedures didn't exist for ordinary mechanics. Training programs couldn't prepare tank crews for the system's operational peculiarities. By August 1944, both Maus prototypes were operational yet consuming resources at impossible rates. Every test run required teams of engineers, specialized fuel trucks carrying high-octane diesel, and recovery vehicles able to tow 188 tons of disabled tank. The V2 prototype had received its operational turret and main gun, making it the most powerfully armed tank ever built. Yet the complete vehicle was so intricate, so fuel-hungry, so maintenance-intensive that it barely functioned outside the test facility's controlled environment. June 9, 1944 marked the peak of Porsche's obsession when the V2 prototype received its first operational turret at the proving grounds. The enormous 55-ton turret, manufactured at Krupp's Essen works, housed the devastating 128mm KW K-44 gun, alongside a coaxial 75mm weapon, more firepower than most Allied tanks carried as their sole armament. When hydraulic systems raised the turret into position and locked it onto the hull ring, the complete Maus weighed 188 tons and towered over 12 feet tall, a land battleship that dwarfed every other armored vehicle in existence. The first live fire test confirmed Porsche's boldest promises. The 128mm gun firing armor-piercing rounds at muzzle velocities of 900 meters per second punched through captured Sherman and T-34 hulks at ranges exceeding 3,500 meters. The massive projectiles didn't merely penetrate, they obliterated entire tank sections, sending turrets spinning through the air like toys. Against the thickest Soviet armor available, the IS-3 heavy tank, the Mause's gun achieved complete penetration at distances that made enemy return fire impossible. For those moments on the firing range, watching Allied tanks disintegrate beneath his weapon's fury, Porsche believed he'd created the invincible breakthrough weapon Hitler craved. Yet even as the Maus demonstrated its devastating power, industrial mathematics were shifting decisively against Germany. At Chrysler Arsenal in suburban Detroit, production lines achieved unprecedented efficiency in tank manufacturing. Originally designed for automobile transmissions, the facility had been converted to Sherman production using Henry Ford's assembly line principles. Workers who'd previously installed carburetors and differentials now assembled tank transmissions and final drives using identical standardized procedures. Each Sherman M4A3 demanded exactly 75,000 man-hours from raw steel to combat readiness, and Chrysler was completing one tank every hour during peak shifts. The contrast with German methods was becoming glaring. American workers followed simplified assembly procedures using interchangeable parts. Each Maus prototype required hand-fitting of custom components by master craftsmen. The electric transmission system alone demanded specialists who understood Porsche's unique motor generator sets. Technicians capable of adjusting electrical controls with watchmaker precision. The Krupp works where Maus turrets were manufactured employed the same time-intensive methods used for naval gun mounts. Multiple heat treatments, precision machining, individual testing of every component. Meanwhile, Soviet tank factories beyond the Urals had reached production levels German intelligence initially dismissed as propaganda. Factory 183 in Nizhny Tagil was completing 1,300 T-34s monthly using workers evacuated from Ukraine and Belarus. many of them women and teenagers trained in tank assembly within weeks. The T-34's deliberately simplified design eliminated components requiring skilled metalwork, substituting mass production techniques for individual craftsmanship. Armor plates were cut by flame rather than machine tools, welded by minimally trained workers and assembled using the fewest parts necessary for battlefield effectiveness. The Mouse's operational testing revealed the fatal contradictions in Porsche's perfectionist approach. During sustained trials at Kummersdorf, the V2 prototype's diesel engine suffered catastrophic crankshaft failure after only 47 hours of operation. The massive Daimler-Benz power plant, stressed beyond its design limits by the tank's enormous weight, had developed hairline fractures that propagated through forged steel until failure became inevitable. Replacement engines required custom manufacturing at Mercedes-Benz facilities in Stuttgart. A 6-week process consuming resources equivalent to building 3 Panther tanks. While German engineers struggled keeping 2 Maus prototypes operational, Soviet tank crews at Stalingrad were driving T-34s directly from factory floors to combat positions 200 meters away. The simplified Soviet tanks needed minimal preparation. Fuel, ammunition, and a quick systems check before crews drove them into battle against German positions. Many T-34s entered combat still wearing factory primer paint. Crews learned operational procedures during the short drive to the front. Soviet tactics had evolved to exploit this manufacturing advantage. Sacrifice 2 T-34s to position a third for a killing shot against German armor, accepting losses that German industry could never sustain. The Battle of Kursk in July 1943 had already demonstrated the futility of German quality over quantity thinking. Despite deploying their newest Panthers and Tigers, German armored spearheads were overwhelmed by waves of Soviet tanks, absorbing enormous casualties while inflicting proportionally devastating losses on irreplaceable German equipment. Each destroyed Panther represented months of skilled labor and scarce materials Germany couldn't replace, while each T-34 loss was offset by 5 more rolling off production lines within days. Porsche's engineering team, isolated in their Stuttgart workshops and Kummersdorf test facilities, remained focused on solving technical challenges while the strategic situation crumbled around them. They developed ingenious solutions to the Mouse's cooling problems, designing variable speed fans and improved radiator configurations. They refined electric transmission controls, achieving smoother acceleration and more precise steering responses. They even solved river crossing challenges, perfecting snorkeling equipment that allowed one Maus to remain submerged for extended periods while its partner provided power through umbilical cables. But these technical victories meant nothing against the industrial tide flowing against Germany. American Lend-Lease shipments were delivering thousands of Sherman tanks to Soviet forces, supplementing domestic T-34 production with reliable, well-equipped vehicles that Soviet crews praised for their mechanical reliability and superior optics. British factories were producing Churchill and Cromwell tanks using manufacturing techniques pioneered in automobile production, while Canadian plants manufactured Ram tanks that freed American production capacity for other vehicles. By September 1944, the Maus had achieved its peak theoretical performance during controlled testing at Kummersdorf. The V2 prototype, with all systems functioning optimally and its crew thoroughly trained in the tank's unique procedures, achieved a maximum speed of 22 kilometers per hour on perfect concrete surfaces. The electric motors delivered smooth, precise power to both tracks, allowing the massive tank to pivot with surprising agility despite its enormous weight. The 128mm gun could engage targets with devastating accuracy at ranges making enemy return fire impossible, while thick armor protection rendered the tank effectively invulnerable to every Allied anti-tank weapon in service. Yet Germany lacked the fuel to train crews in the Maus's complex operations. The tank, designed for breakthrough assaults, consumed 400 liters of diesel every 100 kilometers, fuel that could keep a company of Panzerfausts operational for weeks. Specialized maintenance requirements meant each Maus needed a dedicated technical crew with months of training expertise Germany's shrinking pool of skilled workers couldn't provide. Most critically, Resources consumed by the two prototypes, steel, electronics, precision manufacturing capacity, engineering talent, could have produced 25 Panther tanks or 50 Panzer IVs that could actually reach the battlefield and engage enemy forces. The final irony of Porsche's masterpiece was becoming clear to everyone except Porsche himself. The mouse that would devour enemy armor had become a resource-consuming monster, devouring Germany's capacity to build practical weapons. While Porsche's engineers achieved ever greater technical refinements, Allied factories were perfecting the brutal arithmetic of industrial warfare. Adequate weapons produced quickly would always defeat perfect weapons. The breaking point arrived on October 27, 1943, when Albert Speer finally convinced Hitler to cancel the production order for 150 Maus tanks. In Speer's austere office at the Reich Ministry of Armaments, surrounded by production charts revealing Germany's deteriorating industrial capacity, the pragmatic architect-turned-minister presented Hitler with numbers that even the Führer's romantic vision couldn't ignore. Each Maus prototype was consuming resources equivalent to 5 Panther tanks, while German armored divisions on both fronts were reporting critical shortages of replacement vehicles. The arithmetic was brutal and undeniable. Germany could build 2 perfect tanks that couldn't reach the battlefield, or 100 adequate tanks that could engage the enemy immediately. Hitler's reluctant agreement to limit production to the 2 existing prototypes marked the beginning of the end for Porsche's grand vision, but the obsessive engineer refused to accept defeat. At his Stuttgart facility, Porsche continued refining the Maus systems with characteristic intensity, burning through precious fuel and steel while Germany's strategic situation crumbled. His engineering teams worked 18-hour shifts, perfecting electric motor controllers and diesel generator assemblies, achieving technical breakthroughs that would have been revolutionary in peacetime but were meaningless in a war Germany was losing through sheer industrial attrition. The contrast between German perfectionism and Allied pragmatism was becoming stark across every aspect of tank production. At Detroit's River Rouge plant, Henry Ford's production engineers were applying assembly line principles to Sherman manufacturing with devastating efficiency. The same workers who'd built Model T automobiles before the war now assembled tank hulls using standardized procedures that eliminated skilled craftsmanship in favor of rapid throughput. Each Sherman demanded exactly 75,000 man-hours from raw materials to battlefield delivery, a figure Ford's industrial engineers had reduced through systematic study of every manufacturing step. The Soviet system had adopted an approach built on relentless efficiency and sheer output volume. Behind the Urals, far from the reach of German bombers, the Chelyabinsk tractor plant transformed into factory number 200. Here, T-34 tanks rolled off assembly lines 24 hours a day, 7 days a week. Workers learned to build tanks in weeks, not the years traditional methods demanded. The factory's director, Isaac Saltzman, had come from an agricultural background, yet he possessed a gift for stripping away everything unnecessary. Every non-essential element vanished from the T-34 design. If it didn't contribute directly to fighting capability, it got removed. Interior panels stayed bare metal, unpainted and rough. Electrical wiring was minimal, the absolute minimum needed to function. Armor plates came straight from flame-cutting torches rather than machine shops, their rough edges left as they fell. The numbers spoke volumes about where the war was headed. In 1943 alone, American factories produced 29,497 tanks of every description. The Soviets matched this with 24,000 tanks and self-propelled guns combined. Germany managed barely 11,000 vehicles that same year. Many of these were Panthers and Tigers, magnificent machines that demanded constant maintenance and consumed fuel at terrifying rates. At the Hensel Works in Kassel, quality control officers watched the Maus project with mounting dread. The steel going into those 2 prototypes could have produced 20 additional Tiger IIs, tanks actually reaching the front lines and seeing combat. The specialized electronics and precision components destined for Porsche's electric transmission system could have outfitted hundreds of standard tanks with better fire control or improved radio equipment. The Battle of Kursk had already exposed the flaw in Germany's philosophy. Concentrate your newest Panthers and Tigers in attacking spearheads, and they still got overwhelmed by waves of Soviet tanks. The Germans lost irreplaceable equipment, while the Soviets absorbed casualties and replaced their losses in days. Soviet commanders had learned to use expendable T-34s as bait, finding German positions, then crushing them under concentrated firepower. Every German tank lost meant months of skilled labor, and scarce materials vanished forever. Every Soviet tank lost got replaced within a week. Porsche remained detached from these strategic realities, consumed entirely with achieving technical perfection. During autumn testing at Kummersdorf, his engineers solved the Maus's chronic overheating through redesigned cooling systems with variable speed fans and improved airflow passages. Electrical control problems that had plagued earlier trials disappeared. The tank accelerated smoothly, responded precisely to steering commands despite its enormous weight. The snorkeling equipment worked perfectly now, allowing the Maus to remain completely submerged for extended periods, crossing rivers that would stop any conventional tank. Technical achievements accumulated, but they existed in a strategic void. Germany couldn't produce the fuel needed to train Maus crews in its complex procedures. Each Maus demanded a dedicated technical team requiring months of specialized training. Germany's pool of skilled workers was shrinking daily. Allied bombing campaigns methodically destroyed precision manufacturing facilities across Germany and occupied Europe. The Maus's complexity created fatal vulnerabilities. Components came from dozens of specialized suppliers scattered across the continent. Daimler-Benz engines originated in Stuttgart. Krupp manufactured turrets in Essen, Siemens provided electrical systems from Berlin, and ammunition came from factories in Pilsen. Each facility represented a critical weakness that Allied planners systematically targeted. Sherman production operated differently entirely. Multiple manufacturing facilities produced interchangeable components using standardized procedures. When German U-boats attacked American shipping, alternative suppliers stepped in without disrupting production schedules. When Allied bombers hit German factories, entire product lines collapsed because single facilities produced irreplaceable specialized parts. The strategic bombing campaign exposed a fundamental contradiction in German industrial strategy. American B-17 and B-24 bombers, themselves products of mass production methods, destroyed German manufacturing capacity faster than it could be rebuilt. The precision tooling and skilled workers necessary for Maus components were systematically eliminated, while American factories expanded output using simplified procedures and replaceable workers. In September 1944, the Maus V2 reached its operational peak during final tests at Kummersdorf. All systems functioned optimally, its crew thoroughly trained in the tank's unique capabilities. The massive 128mm gun could engage any Allied tank at ranges exceeding 3,000 meters. Thick armor rendered enemy fire ineffective. The electric transmission provided smooth, precise control despite the enormous weight. Improved cooling systems allowed sustained operation without overheating. Yet Germany lacked the fuel to deploy the Maus operationally. The tank consumed 400 liters of diesel every 100 kilometers. Fuel that could keep an entire company of Panzer IVs running for weeks. Specialized crew training consumed months Germany's desperate situation couldn't spare. Maintenance demanded technical expertise, increasingly unavailable as skilled workers were drafted into infantry units or killed in bombing raids. The final irony became undeniable. The tank designed to end all tanks couldn't even reach the battlefield to prove its worth. Porsche's masterpiece achieved technical perfection during controlled testing, while German armored divisions fought desperate defensive battles with inadequate numbers of conventional tanks. Many of them obsolete models outmatched by the latest Allied armor. April 21, 1945 arrived without mercy. Soviet T-34s from the 3rd Guards Tank Army smashed through Berlin's outer defenses, while Porsche's masterpiece faced its final humiliation. The Maus V2, sent to defend Army Group Center headquarters at Zossen, managed exactly 11 kilometers before its transmission failed completely. German recovery crews lacked the specialized equipment to tow 188 tons of dead weight. They made the only choice available. Explosive charges placed in the engine compartment and turret ring reduced 3 years of obsessive engineering to twisted scrap rather than let Stalin's forces capture it intact. Soviet engineers reaching the destruction site on April 23 found a technological enigma demanding careful interpretation. Senior Lieutenant Mikhail Sverkin of Red Army Technical Intelligence surveyed the wreckage with professional detachment, noting the massive proportions and unusual electric transmission components scattered through the debris. It took 18 tons of German half-tracks commandeered from a nearby supply depot to lift the 55-ton turret clear of the hull. The Soviet preliminary assessment remained diplomatically restrained but privately devastating. Impressive firepower, impregnable armor, but ultimately a tactical dead end representing everything misguided about German military thinking. The Maus program's final accounting revealed staggering costs. Germany built exactly 2 operational prototypes at a price equivalent to 125 Panzer-4s or 53 Panthers. Specialized tooling, precision manufacturing equipment, and engineering expertise consumed by the project could have equipped entire armored divisions with proven battle-ready vehicles. The aluminum, copper, and rare earth elements used in the Maus's electrical systems represented strategic materials Germany desperately needed for aircraft and submarine construction. While Porsche's engineers pursued their vision of invincible armor, Allied production lines achieved industrial dominance through radically different principles. American factories completed 49,422 Sherman tanks during the war. Each one proved adequate for its mission, manufacturable using standardized procedures. The Sherman's 75mm gun penetrated most German armor at combat ranges. Mechanical reliability kept it operational under field conditions. Its weight allowed deployment anywhere roads and bridges existed. Most critically, Sherman production could expand or contract based on strategic requirements without disrupting the entire manufacturing base. Soviet tank production reached even more staggering totals through systematic simplification. The T-34, derided by German engineers for crude construction and loose tolerances, achieved battlefield effectiveness through overwhelming numbers and continuous improvement. Soviet factories produced over 57,000 T-34s of all variants, each representing successful balance between firepower, protection, mobility, and manufacturability. Sloped armor and high-velocity guns made them competitive with German vehicles costing 3 times as much to produce. Training and operational deployment revealed the contrast starkly. Sherman and T-34 crews learned their vehicles in weeks using standardized procedures applicable across thousands of nearly identical tanks. Ordinary mechanics performed maintenance using common tools and readily available spare parts. Field workshops could often repair combat damage using components salvaged from other vehicles. The Maus required months of specialized training for each crew member, custom manufactured parts available only from German factories, and maintenance procedures demanding master craftsmen rather than ordinary soldiers. Strategic implications became apparent during the war's final campaigns. As German forces retreated, they abandoned hundreds of Panthers and Tigers due to mechanical failure, fuel shortages, or missing spare parts. Each immobilized German tank represented months of irreplaceable industrial capacity lost. Soviet armored spearheads maintained momentum by cannibalizing damaged T-34s for spare parts, transferring crews between vehicles as needed, and accepting mechanical reliability over individual superiority. The technological sophistication Porsche pursued so obsessively proved counterproductive under wartime conditions. The Maus's electric transmission, revolutionary in theory, required constant adjustment by specialists understanding its unique characteristics. The 128mm gun, capable of destroying any Allied tank, fired ammunition so heavy that crew fatigue limited combat effectiveness after a few dozen rounds. Armor protection that repelled every Allied anti-tank weapon made the tank too heavy for tactical mobility and too expensive for mass production. Allied medium tanks faced different requirements entirely. The Sherman's 75mm gun, while inferior in penetration and range compared to the Maus's larger weapon, fired lighter ammunition, allowing sustained combat operations. Its 30-ton weight permitted rapid movement across varied terrain and deployment wherever logistics could support operations. Most importantly, the Sherman could be produced quickly enough to replace combat losses while maintaining numerical superiority. The Battle of the Bulge demonstrated these principles brutally during Germany's final offensive. German forces deployed their most advanced tanks in concentrated spearheads designed to achieve breakthrough through individual superiority. Initially successful, these elite units gradually fell to American armored divisions that absorbed enormous casualties while maintaining combat effectiveness through rapid replacement of men and equipment. The surviving Maus prototype, assembled from the V-1 hull and V-2 turret by Soviet engineers, became a museum piece at Kubinka testing facility outside Moscow. Surrounded by examples of successful wartime tanks from all nations, Porsche's masterpiece stood as monument to engineering brilliance applied without strategic understanding. The tank, supposed to dominate every battlefield, never fired a shot in anger, never engaged an enemy vehicle, never justified the enormous resources consumed creating it. The real victors of the tank war were industrial engineers understanding that adequate weapons produced quickly always defeat perfect weapons produced slowly. Henry Ford's assembly line techniques applied to Sherman production proved more decisive than German engineering excellence. Soviet manufacturing methods prioritizing quantity over individual quality overwhelmed German technological superiority through sheer numerical dominance. The lesson embedded in the Maus's failure extended far beyond tank design to encompass the fundamental nature of industrial warfare. Modern conflicts would be won not by individual weapons, however technically superior, but by industrial systems capable of producing adequate equipment in overwhelming quantities. The factory worker assembling 10 medium tanks proved more valuable than the master craftsman building one perfect supertank. Ferdinand Porsche's Maus had indeed roared, but its voice was drowned out by the thunder of 49,000 Sherman tanks rolling across Europe's battlefields. The perfectionist engineer who revolutionized automotive design learned too late that in war, the adequate solution implemented immediately defeats the perfect solution arriving too late. The tank designed to end all tanks instead demonstrated that in the arithmetic of industrial conflict, quantity possesses a quality all its own.